Okay, class, video is going to be a demonstration for lab 12, which is basically acid-base titration is the topic, and so the objective will be to perform a titration, an acid-base titration. We're going to use phenolphthalein as an indicator. So probably going to do this in two parts, and we'll go over this in lecture with respect to the pre-lab. But I am going to require everybody to read the pre-lab and look at the calculations and what's required for that in terms of titrations. In terms of overall equipment and materials, you're going to need some beakers. You're going to need your test tube rack with these little wells that we're going to do the titrations in. You're going to need some calcium hydroxide in your kit, phenolphthalein, and also some vinegar. So we're going to use vinegar. Acetic acid will be our acid. And we're going to make a calcium hydroxide solution, which will be our base. So a couple steps here will be to first make a solution of calcium hydroxide as our base. And we'll have to make that and then filter it. And then the second part will be making our solution of vinegar. And we'll use that to titrate. So let's make our solution of calcium hydroxide first. Okay, so we're going to make our solution of calcium hydroxide, which is our base solution. So we're going to start with about 100 mils of water in a beaker, and then we're going to add calcium hydroxide to that. So here I've got a little bit of water here. I'm going to start with 100 mils. We have about 100 mils in my graduated cylinder here. Okay. I'm going to add that to a beaker. And then it says to add how much? Add a spoonful of calcium hydroxide to the water and stir. Let's sit for several minutes. Once we get it saturated, make sure it all dissolves. And if it all dissolves, then we add more until it's saturated. After about 15 minutes. So let's take our calcium hydroxide. Here's our calcium hydroxide. And we're going to take this 1 level spoonful of it, and we're going to add to the water, and then we're going to stir that and let it settle. And this will become our base solution after we filter it. So then we're going to filter it. We're going to set up our filter paper like we usually do. We're going to fold it in half and then in half again. And then we're going to put it in our Buchner funnel, and we're going to filter this till it's all clear. Okay? So we've kind of done this filtration before in our previous labs. So I'm going to stir that, let that mix for a few minutes, filter it, and then we'll have our calcium hydroxide solution. Okay, class, so I've given this a few minutes. I've stirred it several times. This is the calcium hydroxide solution. I'm going to let it sit for a few minutes. Let it set so that the precipitate goes to the bottom. It'll filter more quickly. Filter the more clear liquid first, and then pour the rest of it over through the filter paper so it doesn't clog so quickly. Then we'll have our calcium hydroxide solution, and we're going to put it in a separate container and label it. So we'll have that, and then we'll come back and we'll make our acetic acid solution out of vinegar, which will be a series of dilutions, which I'll show you here in a minute. So this will take a little while to filter, dissolve and filter, and then label and set the calcium hydroxide solution to the side. That'll be our base. Okay, class, so you can see that I'm filtering now the calcium hydroxide, saturated calcium hydroxide solution using my funnel, filtering funnel, filter paper, and Buchner funnel. And I kind of use a glass stirring rod just to kind of decant into the center of the paper. So I get most of the clear liquid through the filter first. That makes the filtration go more quickly than to add all the solid onto the filter paper right away. So We'll let that filter for a while. We want to collect at least 70 mils. So we're going to filter the entire solution, and then we're going to set it aside as our base. Okay, class, the calcium hydroxide solution is just about filtered totally. I'm going to let it sit for a couple minutes so the last few mils of solution drain into that flask, and then I'm going to put it in a labeled container, calcium hydroxide. That will be our base. So now we're going to make our acid solution, acetic acid, and this is called a serial dilution process. Well, we'll take 20 mils of acetic acid directly from the container, 20 mils, mix it with 80 mils of water to make 100 ml total volume. Then we're going to take 20 mils of that solution and dilute it again by the same amount. So we'll end up with 1/25th dilution of our original solution. So important that you measure the volumes as accurately as possible with your graduated cylinder so you don't shoot over the target volume, and you can use your pipette to do that by adding the solution dropwise. So let's start with getting our 20 mils of acetic acid, and I'm just going to use this container, the little container I have here, a little jar, as an extra container because you're going to need them to make the serial dilution. So we're going to dilute up to exactly 20 mils. So you're going to have to hold that up and be sure you can read the volume, and then you can add the last few mils with your pipette to get exactly 20 mils. So let's do that. So let's use our pipette, and we will add a couple drops until we're right at 20 mils. Okay, a little bit more. Maybe one more. So if you add this dropwise, you'll get an accurate volume reading for your acetic acid and make a stock solution. Okay, that's pretty good. So that's exactly 20 mils. Now, we're done with this, so we can rinse the acetic acid down the sink that was strong, undiluted. And now we're going to add 20 mils of water. So we're going to use our pipette again. So you got to keep your pipette clean, rinsed thoroughly, so you don't cross-contaminate with anything that was in the pipette before you used it. So I'm going to rinse that with water, and then we're going to add up to 100 mils. This is a beaker of tap water. So we're going to add up to exactly 100 mils. Don't overfill it. You use the pipette again to top it off. So we'll add up to 90. Slowly, slowly, slowly. And then we get to the end. What you can do, use your pipette again to top it off. So we'll add a few mils with the pipette, just so it's accurate. And we still need about 1.5 mils here. Okay. Maybe a couple more drops. Okay. So now we've added 20 mils of acetic acid plus 80 mils of water for a total volume of 100. And now we're going to dump that, add that to another beaker, and we're going to stir that. We'll get a nice solution now of dilute acetic acid, and then we're going to do the same thing for this solution. We're going to dilute it again, same amount, 20 to 80. So let's rinse this. Rinse the graduated cylinder so it doesn't have anything in it from before. And that's just water. We're going to need water again to dilute, so let's add more water to this beaker. And now we're going to take 20 mils of our first dilution. So let's measure 20 mils exactly again like we did before. I gotta hold it up so I can see. It's a little difficult to read these white graduated cylinders. And we're going to take it up to about 18. And then again, we're going to use our pipette to get an accurate value. Now you can rinse it out by just taking your pipette, squeezing the bulb, and adding solution, and then just rinsing it in the sink. So you don't add it directly yet. About 3 times, 3 or 4 times. And now we take it and we add it to get our 20 mils exactly. And get the bottom of meniscus. So that's 20 mils right there. Now we're going to add another 80 mils of our water. Exactly. So we're going to take this up to 100 volumetrically. Okay, and we're going to add the last few. Again, rinse the pipette with the water. So squeeze it and then suck the water up, rinse it about 3 or 4 times, just like that. So you know it's just water and the pipette. And then we're going to add it till we get exactly 100. Okay, drop wise, that looks good. Okay, so now we have our final dilution. So let's rinse this out. Our beaker here. Do a lot of rinsing in this lab, so be sure we don't cross-contaminate solutions. Now we're going to take our last dilution where we took 20 and 80 mils, and we're going to add it to the beaker and we're going to mix it. This will be our final solution, acid solution that we're going to titrate with our calcium hydroxide. So we'll mix that. We're going to put that in a little container I've labeled acetic acid. We don't know the concentration yet. We're going to determine that when we do our titration. Okay, so we'll put that in a container that's labeled acetic acid. Careful not to spill it. Use whatever container you have. And now it looks like our calcium hydroxide solution is finished filtering. So we're going to add that to our container of calcium hydroxide here. So we put those in a clean container, and now we have our 2 stock solutions that we can do our titrations with. And that'll be part 2 of the lab. So just to summarize, you made a saturated solution of calcium hydroxide, filtered it, and then need at least 80 mils to of clear saturated calcium hydroxide solution you're going to use as your base. Then you took acetic acid and you took 20 mils of acetic acid concentrated to 80 mils of water, mixed that, took 20 mils of that with another 80 mils of water, mixed that to give you your acetic acid solution. Okay, so that is how you make the 2 solutions, and the next step will be to do the titrations, which I will show in part 2. Okay, class, now I'm going to show you how to do these titrations with phenolphthalein indicator. And as in the first part I showed you, we have our solutions of acid and we have our solutions of base. Calcium hydroxide is our base and acetic acid is our acid. We're going to add 5 drops. Let's start with 5 drops. I've tried this with 5. You can use 5 to 10 drops of acetic acid. And we're using our wells in our test tube rack holder. Those little round indentations in your holder. We're going to use those little wells to titrate, to do our titrations. I've rinsed them out, so they should be dry. You have to count the drops now. Be sure you accurately count the drops that you add when you add the acid and the base. And to start with, and when you add the drops, you have to use the pipette. So the pipette is going to have to be rinsed all the time to be sure that you're not cross-contaminating it. So I'm going to mix it with water right now. Just give a couple squeezes of water to be sure there's nothing in there. And then we start. We're going to add 5 drops. Now you're going to do this 5 times. 1, 2, 3, 4. Actually, you do it 6 times if you want. What's it say? You have 6, yeah. So you can do it 6 times. This is good. You're going to do replication so you get a good average. And again, be sure you count the drops that you're adding when you fill that into your chart. Now it has volume of acid as 10 drops. I'm going to try 5, or you can use 10, but let's try 5 first. So let's start with our acid. We're going to add 5 drops to the first one. So let me rinse my pipette with the acid a couple times. Okay, and then we're going to take, make sure you don't get any air in the pipette so you get full drops. I'm going to add 1, 2, 3, 4, 5 drops of acid. Okay, then we're going to rinse this. You might dab it. I dab it on a paper towel just to get the rest out, and then rinse it with water a couple times. And we're going to set that to the side. Now we add our indicator, and we're going to add 1 drop of our phenolphthalein indicator. Now, because it's acid, it should not change pink yet until we add the base. We're going to add 1 drop of indicator. Okay, I think that was enough. One of the things I didn't show you at the beginning was to have toothpicks. You're going to use toothpicks to mix the solutions as you titrate with the base. So now we have our acid solution with our indicator. And as we add base, the indicator will cause the solution to turn pink as the pH goes up and we add more base. So let's start by adding our calcium hydroxide solution. Let's rinse our our pipette with a couple volumes of calcium hydroxide to be sure our pipette is not contaminated. And be sure there's no air in the pipette. Hold it vertically. Now let's add 1 drop and see what happens. And you see that it turns pink right away. So then we will stir it with a toothpick and the pink will go away. Now let's add another drop. And it turns pink. So that's 2 drops. Stir it. And it goes away. Add a 3rd drop. 3. Okay. It's like a little longer to go away. 4 drops. Okay. And it looks like after 4 drops, it's not going away. So we've reached our equivalence point, which was defined in the beginning. So let's be sure we record that in our lab book, in our lab procedure, where for the first trial, we had 5 drops of acid, not 10, as it says here, and we had 4 drops of base. Okay? Why don't we try and add 10 drops of base and see what happens, and see if we get, I'm just want to be sure it doesn't overflow. Let me rinse my pipette a couple times, and now let's do the second one. We'll use 10 drops of base, 10 drops of acid. So let's rinse this out. Nice being near a sink. 2, 3, and now we're going to add 10 drops of base to the second one instead of 5, just to see how that works. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that was 10 drops of acid. And we're going to rinse this pipette with water so we don't forget. Have that handy, lay that to the side. Now we're going to add our 1 drop of indicator. So we know when we've reached the end point. Okay, we added our drop of indicator. Now, we're going to titrate with our calcium hydroxide. This should take more, obviously, because we've got more acid in there. So let's rinse our pipette with the calcium hydroxide. And again, count your drops. Okay. So let's do 1. Turning pink already. So we'll stir that. It goes away. 2, let's add 3. Turning pink, goes away. 4 drops. Yeah, it's getting pretty full. 5. 6. One more should do it. 7. And that's our end point. The pink is not going away after stirring with the toothpick. Okay, so now we've got a little bit different data here. So we have 10 drops of acid and we had 7 drops of base. So you'll do this for another 4 trials, the same procedure. Be sure you count the number of drops of acid, add your indicator, and count the number of drops of base, the calcium hydroxide, and then you will use your numbers to determine the concentrations of, or the molarities. Because we know the molarity of acetic acid, we estimated that at the beginning because we know how much acetic acid is in our original container. So we'll talk about that in class. But we'll estimate, we know how much our molarity of acetic acid is, we know the volumes and drops of each, so we'll be able to determine our molarity or concentration of our stock calcium hydroxide based on our titration. Okay, so hopefully that makes some sense, and we'll talk about this in class.